This is part 232, line 20D. Diagnosis, diabetes, density, isotopic, kinetics, D2H2 energy, Wow Seti. There's the alien radio signal there with the equations. May 15, 2012, and just so you know, today's June 14th. So let's Google D2H2. I wanted to find out what else I could find about it. So I go to jcp.aip.org. and I found this distributed diagnosis in home healthcare D2H2. Okay, so it's some sort of PDF or something. Oh, it's a book. Distributed diagnosis in home healthcare D2H2 is an outgrowth of the miniaturization and integration of instrumentation, wearable and implanted, for measurement, computing, signal processing, communication, and healthcare informatics. This integrative systems approach will revolutionize the practice of medicine in the new century, enabling the delivery of healthcare to patients anywhere in the world by combining biosensing and information technologies with medical expertise. It will facilitate the transition from central and hospital-based medical diagnosis and healthcare delivery to distributed diagnosis in home healthcare D2H2. This book is divided into two parts. Part 1 is devoted to distributed diagnosis, and part 2 is devoted to home health care. Part 1 of this book deals with distributed diagnosis. The chapters throughout part 1 cover a wide range of areas, including a comprehensive study of the diabetic foot, an analysis and detailed classification of plantar pressures with and without diabetes type 2, and a study of the features extracted from the various kinds of fundus. Actually, it looks like it could be fungus, but they've got fundus. Eye images, namely normal, mild, moderate, severe, and prolific diabetes retinopathy, which are fed to the feed-forward classifier for classification into normal, non-proliferative, and proliferative diabetes retinopathy classes. Part 2 of this book deals with the home healthcare system, home healthcare appliances, solutions, and motion analysis for the clinical rehabilitations are discussed. One study deals with the personalized cardiac monitoring for monitoring cardiac state and vital signs by non-intrusive monitoring. Finally, the book concludes with the ethics in D2H2 and the future of the healthcare system, leading to the next generation of research topics that will directly impact distributed diagnostics in home healthcare. The book takes a comprehensive look at biomedical instrumentation, biosignal processing, data mining applications, medical imaging, bioinformatics, and modeling, and medical networking tools that support telemedicine and more broadly distributed diagnosis in home healthcare. So that's at www.aspbs.com. The next thing is a PDF file that comes up. It says density induction times in very lean mixtures of D2H2, C2H2, and C2H4 with O2 from Donald White, and he's from Satanaki, New York, USA. And that's from 2007. The induction time for shockwave-induced exothermic reaction in lean, there's the equation there, has been measured in the constant area shock tube using optical interferometry for fuel oxygen ratios of a few percent and for 1100 to that. The gas time from the shock to the first decrease in density is given by the following: moles per liter seconds and 0 degrees of K. So there's the equations there. Okay. Again, you'll be able to see these when I post it with the video on the Victoria Stafford, a psychic investigation blog on WordPress, okay? Essentially, the same activation energy of this is shown by H2, C2H2, and C2H4, but that of D2 appears to be slightly less. With respect to H2, the induction time for D2, C2H2, and C2H4 are about 1.5, 0.5, and 0.4 respectively. The more nearly stoichiometric mixtures show induction times inversely proportional to the geometric mean reactant concentration, and the dependence on the fuel concentration increases with decreasing fuel or CO2 ratio. Dependence on 0.2 vanishing for the leanest 0,2 minus C2H4 mixtures. The vibrationally relaxed but unreacted density is always attained prior to exothermic reaction. In changing the relaxation time with respect to the induction time has no effect on the latter within the data scatter. 1967, published by Elsevier, Inc. We had a lot of their stuff come up. Elsevier did. www.sciencedirect.com. Oh, here's another one. Isotopic exchange in C2. I'm having a hard time saying all this, so I'll just let you read it. Catalyzed by triphenylphosphine. This reminds me of when we used to do spelling bees. I'm glad I never had to spell that word. Nickel 2 halide, sorry. Naoki Ando, Kenichi Marua, Tatsumoto Mizogoki, Atsuzumo Ozaki. Research Laboratory from Tokyo, Japan. March 1970. This is an oldie one. Okay, so it's an abstract, so it's a PDF or some sort of test result here. Abstract. Bis-trisphenyltene nickel 2 halide has been found in the catalyzed CHD exchange reaction of C2D4 and C2H4 in the presence of molecular hydrogen at room temperature, in spite of the fact that the rate of exchange between H2 and D2 is very slow. From the kinetics of this reaction and solvent effect, it has been postulated that this bi-trisphenylphosphine nickel 2 halide forms a nickel hydride complex by the heterolytic splitting of hydrogen molecule in the course of the reaction as follows. So basically, with this PDF, you're going to want to look at how they did the splitting of the hydrogen molecule. That seems to stand out here. So there's the equation there of what they did. Okay, something to do with splitting this hydrogen molecule. The nickel hydride complex, we're probably going to use this hydrogen molecule, whatever, to create a fusion reaction, because that's the type of reaction we're looking for, a fusion, right? The nickel hydride complex plus thus formed is concluded to be the real catalyst for the HG exchange in ethylene by the scheme of that. Okay? ScienceDirect.com, 1971. Next, March 2006. Tunneling chemical reactions of D plus H2 to DH plus H and D plus DH to D2 plus H in solid D2H2 and HDH2 mixtures, an electron spin resonance study. From Kamura T. Source, Advanced Science, Japan. Abstract, tunneling chemical reactions from D plus H2 to DHNH and D plus DH, D2 plus H in solid HDH2 and D2H2. Mixtures were studied in the temperature range between 4 and 8K. These reactions were initiated by UV photolysis of dye molecules doped in these solids for 30S and followed by measuring the time course of electron spin resonance, ESR, intensities of D and H atoms. ESR intensity of D atoms produced by the photolysis decreases, but that of H atoms increases with time. Time course of the D and H intensities has the fast and slow process. The fast process, which finishes within approximately 300S after the photolysis, is assigned to the reaction of D atom with one of its nearest neighboring H2 molecules. So there's your mathematical equation to look at. Okay, so rate constant for the D plus H2 reaction between neighboring D atom H2 molecule pairs determined to be that and that, and solid HD2, H2, and that, D2, H2 at 4.1 K, which is very close to that calculated based on the theory of chemical reaction in gas phase by Hancock A.L. 1989, 1990. This rate constant was found to be independent of temperatures up to 7K with an experimental error of plus minus 30%. The slow process is assigned to the reaction of d atom produced in a cage fully surrounded by Hd or D2 molecules. Okay. The d atom undergoes the D plus DH reaction with one of its nearest neighboring Hd molecules in solid HDH2, or diffuses to the neighbor of H2 molecules to allow the D plus H2 reaction in solid HDH2 and D2H2. The former is the main channel in solid HDH2 below 6K, where d atoms diffuse very slowly, whereas the latter dominates over the former above 6K. Rate for the reactions in the slow process is independent of temperature below 6K, but increases with the increase in temperature above 6K. We found that the increase is due to the increase in hopping rate of d atoms to the neighbor of H2 molecules. Rate constant for the D plus HDH reaction was found to be independent of temperature up to 7K as well. Okay? That's www.ncbi.nlm.nih.gov. Next PDF is Crystal Geometry Equations for XRD from geowebprinceton.edu. It's a PDF. It says Crystal Geometry Equations for XRD. D spacings in Miller and Dice symmetry cubic. So you got your cubic here. Remember we were talking about a cube and a matrix for the middle part of the spaceship. So maybe this has something in that PDF. I didn't want to download it, so B. van Windegren, 1979. Another, some more test results here. Partial oscillator strength 25 to 40 eV for repulsive states of D2H2. P. van Windegren. Okay. Abstract. In the range of excitation energies from 26 to 40 eV, there is evidence for the existence of resonant autoionizing Rydberg states in D2H2. In a photonization experiment using fast electron scattering at 0 degrees, the authors have studied the dissociative decay of these states, leading to energetic D plus H plus fragments. After extraction by a strong field, a time of flight analysis was made of all fragments emitted over 4 pi in a photon energy range between 18 and 40 eV. This enabled them to determine partial oscillator strengths for contributions from the 1s sigma G, 2p sigma U, and Rydberg states. The absence of an isotope effect between D2 and H2 for the repulsive states under study shows that for these states there is no competition with decay modes other than autoionization. As a function of photon energy, they find contributions from different Rydberg states, leading to fragments with a kinetic energy distribution centered around 3 eV and 28 eV, and around 1 eV and 35 eV photon energy. Okay, so that's all. May 1979. That's an oldie. That's from iopscience.iop.org. Your next PDF is the bonding in H2 and D2 is identical as they only differ. firstyear.chem.usyd.edu.au. The bonding in H2 and D2 is identical as they only differ in the number of neutrons. What is the ratio of the reduced masses for H2 and D2? The reduced blah blah blah. Okay? Another paper. The effect of D2H2 substitution on the NBN plus H2 reaction from Vaktin and Sagawa. The European Physical Journal of Atoms, 1999. From springerlink.com. Okay? Abstract. The effect of D2H2 substitution on the reactions of niobium clusterations NB, N plus, N equals 5 minus 9. With hydrogen was studied using a Fourier transform, ion cyclotron resonance, FTICR, mass spectrometer, combined with a laser ablation supersonic jet, external ion source. So let's get something to do with jets here. For more cluster sizes, it has been found that the reactions of the NB-N plus clusters with the H2-D2 mixture yield considerable amounts of NB and HD plus, even at small conversions of NB-N plus. These results suggest a mechanism which involves the dissociative chemisorption of H2 on the niobum cluster, followed by the competing stabilization and back dissociation of the energized adduct. That's springerlink.com. See these words here stand out. May 15th, 2012. The effects of D2H2. So those words stand out. A laser ablation supersonic jet arm. In the formula, alien videos, we talk about lasers, supersonic jets, and ion sources. So of course, those words stand out. May 16th, 2012, my thoughts. Creating a formula with all keywords found in the PDF files to see what the pattern means. I will look for repetitive words in this section, and those are the main keywords we need to look at. This integrative system approach will revolutionize the practice of medicine in the new century. Plus, combining biosensing and information technologies with medical expertise. Plus, personalized cardiac monitoring state vital signs, plus clinical rehabilitation, plus proliferative diabetes retinopathy, plus fundus eye images, plus D2H2, plus future healthcare systems, plus next generation of research topics, plus biomedical instrumentation, biosignal processing, data mining applications, medical imaging, bioinformatics, modeling and medical networking tools that support telemedicine, plus home healthcare, plus induction time for shockwave-induced exothermic reaction in lean 02. There's the numbers there. Plus fuel oxygen ratios, plus gas time, plus shock, plus decrease in density, plus moles per liter, seconds, and 0K, or degree K. Plus constant area shock tube using optical informity, plus stoichiometric mixtures, plus induction times, plus geometric mean reactant concentration, plus fuel concentration increases, plus decreasing fuel 0-2 ratio, dependence on 0-2 vanishing for the leanest 0-2 minus C2H4 mixtures, plus H2, C2H2, and C2H4 plus D2 plus, vibrational plus unreacted density, plus exothermic reaction, plus reaction time, plus induction time, plus no effect, plus data scatter, plus nickel hydrate complex, plus HD exchange, and ethylene plus C2D4 plus NiH2 NiC2D4H to C2D3H plus NiD plus halogen plus reaction plus heterolytic splitting of hydrogen molecule plus kinetics plus solvent effect plus bistripholine nickel 2 halide forms a nickel hydride complex plus bistripholestine nickel 2 halide has been found to catalyze the Hg exchange reaction of C2D4 and C2H4 in the presence of molecular hydrogen at room temperature in spite of the fact that the rate of the exchange between H2 and D2 is very slow. Plus ESR intensity of D atoms pholysis, plus H atoms, plus time, plus intensities of D and H, plus electron spin resonance ESR, tunneling chemical reactions, plus D plus H2 to DH plus H, and D plus DH to D2 plus H, and solid H2 to H2, HDH2, and D2H2 mixtures were studied in their temperature range between 4 and 8K, plus D atoms plus H2 molecules plus temperature plus D plus DH reaction plus HD molecules plus solid HDH2 plus diffuses plus D plus H2 reaction plus solid HDH2 plus D2H2 plus D HD12 plus D D212 plus cubic. 1D2 equals H2 plus K2 plus L2, A2 plus crystal geometry equations plus D2H2 plus nibium cluster cyclations NB plus hydrogen plus Fourier transform ion cyclotron resonance FT ICR mass spectrometer plus laser plus ablation plus supersonic jet plus external ion source plus reactions plus chemisorption of H2 plus stabilization plus neutrons plus reduced plus or minus plus reduced mass plus photon energy plus Rydberg stakes, plus kinetic energy, plus 35 eV electron volts, plus oscillator strengths, plus fast electron scattering, plus 0 degrees, plus decay, plus energetic D plus H plus fragments, plus E excitation. May 16th, my thoughts. D2H2 fuel mixtures. Jet propulsion formula ideas are found in these PDF test results. For line 20D, along with many keywords found in the alien radio signal Wow Seti data. When I do the cross-referencing in the future, these formulas and keywords will help me search for videos, blogs that have the same terminology, and putting those formulas together will probably create something really neat. I didn't know what all these test results for EV meant before electronic volts. Nuclear fusion required 25 EVs to work. It also talks about diabetes and eyes. I wonder if astronauts have a problem with that. So I'm going to Google diabetes eyes astronauts and look what comes up. Long space missions may harm astronauts' eyes. Tuesday, March 13th, Health Day News. Extended space travel can cause eye and brain abnormalities in astronauts, researchers have found. Isn't that amazing? For the study published online March 13th in the journal Radiology, investigators used MRI scans to examine the eyes and brains of 27 astronauts who spent an average of 108 days in space aboard the Space Shuttle and or the International Space Station. 8 of the 27 astronauts underwent a second MRI exam after a second space mission that lasted an average of 39 days. The study authors found that among those who experienced a lifetime total of more than 30 days of exposure to microgravity, 33% of the astronauts had expansion of the cerebral spinal fluid space surrounding the optic nerve. 22% had flattening of the rear of the eyeball, 15% had bulging of the optic nerve, and 11% had changes in the pituitary gland and its connection to the brain. These type of abnormalities are seen in cases of intracranial hypertension, for which no cause can be found for the increased pressure around the brain. The pressure causes swelling of the juncture between the optic nerve and the eyeball, which can lead to vision problems. Microgravity-induced intracranial hypertension represents a hypothetical risk factor and a potential limitation to long-duration space travel. Study author Dr. Larry Kramer, a professor of diagnostic and interventional imaging at the University of Texas Medical School at Houston, said in a news release from the Radiological Society of North America. The microgravity-related changes seen in astronauts may help improve understanding of the causes of intracranial pressure in earthbound patients, he added. Vision changes in some International Space Station astronauts have been noted, but the cause is not fully understood. According to Dr. William Tarver, chief of the Flight Medicine Clinic at NASA Johnson Space Center, no astronaut have been listed as ineligible for spaceflight duties as a result of the study findings, which Tarver described as suspicious but not conclusive of intracranial hypertension. NASA has placed this problem high on its list of human risks, has initiated a comprehensive program to study its mechanisms and implications, and will continue to closely monitor the situation, he said in the news release. More information. March 8, 2012. Health and Wellness, BlueCrossMN.com. I have to put in a little funny thing here. Maybe that's why aliens have such big eyes, because they live up in space and their eyeballs grow.